Okay, we are doing Lab 6 Part B today. And I do want to start out by inviting the online people. What I would recommend that you do is, put your name on the, under where it says Edit Name. I have a second one here. I'm kind of be able to monitor the chat window in case anybody's trying to get my attention that way. And so we have this opportunity. This is really nice interface that if you have a microphone, online people can get help on the lab as well as classroom people. So since there's hardly anybody here today, I'll probably have extra time. And but we will need to have a conversation about what's going on. So you can do that after lecture. Turn on your microphone, or just turn on your microphone if you need help, basically. And otherwise, and you can share your screen, and I can see what you're looking at, and offer some suggestions. So we're going to get started with a question from Vincent, which was some hints on the union method. This one's a little challenging just because you've got to work with the interface, and you have to first make the class generic, right? So you have to be able to implement bag interface of T with the class, right? So that's not your question, though, right? Yeah. And why am I not seeing my screen here? Oh, I'm still not projecting my screen. One second. No? Yeah, there we go. And online people, if you're not asking a question, I need you to mute your mic. So that, there you go. So I'm hearing, yeah, cool. Anyway, so remember the point of interfaces, and this is kind of what this is about. This is a really good question for people to kind of get that experience of interfaces. You're going to run into them in the future, and this interface is provided in the download. The interface makes it possible to make a union method that can work with array bags or linked bags. But you're going to write the union method for the linked bag class. But the parameter can be a bag interface object. Any class that implements bag interface should be allowable to pass to the union method, because you'll know it's going to have those same bag methods that you can access, right? So that's the advantage of that. There is a array bag class already defined, and I guess you could write the union method for that as well, but we're just looking primarily at the, well, there was an intersection method that's kind of fun. There's no solution there, but there's a lot of fun things you can do with bags, and to make it really versatile, we would like to make the the union method allowable to work with array bags as well. So you have to be able to say this implements bag interface of T, and the only way you can do that is by making your class generic. And then there's some, it may surface that you have some errors, because once you define this class as implementing bag interface of T, then the compiler is not only going to compile your code to make sure it's syntactically correct, but it's going to check that you've fulfilled the contract listed in the bag interface. And some people might have, I got some questions on Monday where some people were having issues with that. It says, the message will be something like, linked bag is not an abstract class, and it doesn't implement the method, something like remove or something. So I'm not even sure it actually said the method, but
cannot override.
Or cannot override the method remove. Yeah, and it was this case here where people did the generic thing, but they didn't change the return type of object in the linked bag class to T. And that one little mistake is enough to throw the interface check out the window, right? So you had to fix that in their class before they could even write the union method. So making sure that you're consistent, it's a really good exercise, and you all should take a stab at it. This is all good stuff. I don't want to cheat you out of the experience. These are really, professional skills type things that you need to get. And in the past, I've kind of, because of time constraints, I've said these are optional, but I don't want to do that anymore because I don't want to make people think that it's not important. It's very important. Okay.
Set aside on the video, set aside to come in.
Oh yeah, there's nobody here. You heard there was plenty of room.
There's 8 people here.
What were you at the library or something?
No, I was at home.
Oh, that's funny. Well, you got here fast.
Yeah, I live around the corner.
Nice. Well, a few more people have come in, luckily, but still, it's quite empty. I don't know what the deal is. You know what it is? I think it is. Some of the advanced people just probably did the whole lab already. They're like, oh, I'm not coming in. So anyway, that's the first step, is getting the bag interface compiled properly. But then also in the bag interface, there is there is a union method, right? So you'll have to activate that too. Although I think it'll work without the interface. Because the thing is, you can have more methods than the interface specifies. And you would only need that. Actually, you might not be able to do that because then the array bag would have to have that union method as well. So it gets complicated. The interfaces are so annoying, right? You should all get exposed to it at some level. But if you activate the union method in the bag interface, then the array bag is going to have a union method as well, right? So it will not satisfy the contract either, unless there's a dummy. And you can make a dummy method. Oh, there is. There's a dummy method already. So it will satisfy the contract even though it doesn't do anything, right? So that will allow you then to make the bag interface method. Oh, but let's look at that real fast. And notice how the union method is defined. You can use the same same prototype in your linked bag class, right? And look at what it actually says the union method does. It takes a bag interface object, right? It doesn't specify it has to be a linked bag or an array bag. It could be either one. Because if the object satisfies that interface, then you can activate and use all those methods like toArray and all that stuff. And you're going to return a bag interface object. So you're going to define your return value as a bag interface of T, make it equal a new linked bag, because that's the class that you're in. It has to be something specific, a linked bag of T, for instance. And then you can add stuff to it using the various commands of a bag. The pseudocode, I think it gives you some hints here, right? It says what to do here. Activate the union method prototype, define the union method, create a new bag called results, and this will be of type bag interface of T. And you can copy all the items from another bag into result. And it's supposed to be non-destructive. In other words, you don't want to do a union and find out that the initial bags that you provided the union method are nullified, right? Okay. You have to non-destructively copy all the items from another bag into the result. And one way to do that would be to use the toArray method to get the array contents of the bag into an array. You can then, actually, if you're clever, we made a method. Did we make a method for the linked bag that took an array? The constructor, right? Don't we have a constructor that, why is it doing that? Sometimes my computer just does not respond. We made a constructor that takes an array of objects, which is what toArray returns. So you could, right off the bat, make a new bag with that constructor and just give it the array that you get from toArray from another bag. Okay. And then with your own contents, you could activate your own toArray method if you want to, or you could make like a current node reference and just go visit each node and add those nodes one by one to the bag. Okay. Actually, yeah, you can't use the constructor at that point because the constructor can only be used once. Okay. You can use a constructor to make all the contents, make it have all the contents of another bag, and then use a current node reference to visit all of the data in your bag and add those to the result bag. A lot of hand wavy stuff. If you want to give it a shot, you know, I can always help you, but that's the basic idea. But continuing on, today's topic is now going to look at the linked list. And I thought I downloaded that. Let me try that again. Or is it open already? Yes, it is. And so there's some really good. So I'm going to lecture through these things. These are actually really good slides that they have a lot of stuff in them. I was just kind of looking at them. Usually I kind of gloss over because it's really important for you to get the experience. But this lecture is going to kind of look at some of the issues of making a bag. I mean, I keep saying bag. It's going to be now a linked list, right? It's a list that's going to have linked nodes inside it instead of an array. So we're going to continue with our operations on the linked bag that we did on Monday, but now do things that are particular for the list. And there are some interesting things, like I mentioned, and the slides kind of present one way of doing some of these things. Which are kind of interesting. They present some interesting concepts. These are a little bit abstract. So here's the idea. So the issue with a linked list that's a little bit unique to what we're doing, you know, from the way it was with a list of with an array inside of it. Again, when we add a node at various positions, we're going to have to think about the situation when you know, the list is empty. We've already kind of done that with the bag, but how to add a node at the chain's beginning. We've already done that with the bag. So these two, we kind of know these already, right? But the other things that are going to be new for us, like when you want to add a new item between two adjacent nodes that are already in the list. We did that with the array by making those for loops that moved all of the items over one to make room for the new item, right? And you saw that was kind of challenging. We're going to have to do some similar extra steps to do that operation for the linked list. And then, you know, it was really easy to add a node to the end of a chain, to the end of a list when you're using an array, because it's just, you know, go to the size index and add something there, right? With a linked list, adding a node to the end is actually kind of tricky because you actually have to get to the last node before you can add something to it. You have to iterate to the last node with a current node reference to go all the way through all those nodes in the chain before you can actually add something to the end. It's more costly to add something at the end of a linked list than it is at the beginning. So going through those cases, again, this is sort of stuff we did already for the bag class. This is where you create the new node, let the first node equal the new node. This was an empty list, and now we've got you know, first node pointing to that. In the second case, we already did this as well. It's easy to add stuff at the beginning. You just you know, make a new node, set the next node of that. Oh, and by the way, they're using this set next node method. These are like now, you know, where the data fields are private. I'm not following this exact pattern because I think it's kind of extra tedious to do that. So we would be able to say something like, you know, new node dot next equals first node. So you don't have to use that method. And then you set the first node equal to the new node. So this basically, you know, makes the new node refer to all the other items, and then set first node equal to that. Now here's where it gets interesting, because what if you want to add something in the middle of the list? In this case, what you have to do is, and there's actually some extra methods that's provided in the demonstration for us, is that we have to get a reference to the node before the one that we want, before the position where we want to insert the new item. So if you want to insert this new item between like this A and this B, you have to get a node before reference, and so that you can redirect the next field of the node before, right, to point to the new one, right? And you got to get the node after reference so you don't lose it, what comes after in the process of you know, managing this thing, right? So you can say new node.next equals node after. This gives you the flexibility of how to reroute the pointers, reroute those references to add a new node in the chain somewhere in the middle. This code shows you how it works, but again, the textbook provides this get node at method, which you're free to write if you like to, but I just figure out let's just dump all this in the add method and do it right there without a separate method. It's a style thing. And then once you have node before, node after is going to be just node before.getNextNode. It's the node that comes after node before. And then you set new node's next field to node after. Again, this would be new node.next equals node after, and node before.next equals new node. So that's the way you insert an item in the middle of the list. And then at the end, we need a reference to the last node of the chain, which you can get, again, using this get node at method. But again, that's just a for loop inside there that does the iteration to get to the right location in the list before you add a new item. And so that's the idea. So the get node at method is going to want to locate the nth node in a chain. It's going to start at the first node and count nodes as it traverses. And so the pseudocode kind of explains the steps in more detail. So if you want to get the node at position 1, I think that's it doesn't have to advance at all, because you would start the current node at position 1, so it doesn't need to be advanced. But if there's any other node you want to get to, you have to advance a certain number of iterations. So we set current node equal to first node, and then we advance current node equals current node dot next would be the way to do that. Removing a node has some similar issues. If you remove the first node, though, we've already done that. If you want to remove a node elsewhere in the chain, again, you really need to get a node before reference so that you can redirect the next field to point to the one that comes after. So we're getting a node before, a node after, and we're actually also saving node to remove in case, I guess, we want to return that or something. And no, I guess we're just setting it equal to null. And again, there's some questions on whether, did the code that we wrote to add a node between two nodes of a chain, like if we want to add something, of the list, is it possible to use this code, to add something at the end of the chain, in which case we could sort of simplify the number of options in our method so that it's, it's more direct. And the answer in this case is yes. You can use that. This code will actually work if you try to add at the end, and you can kind of get the idea if if the get node at method works properly, it's going to give you the reference to the last node of the chain, and this is going to be null if node before is the last node of the chain, and you're setting the next node to null if you're at the last node, and then node before gets assigned the new node. So that will actually work okay for both situations. If anyone has any questions too, you can stop me. Is this helpful? I mean, I don't have to kind of talk about this if you'd rather just do the coding. I sometimes wonder, some of these concepts are just so abstract, it's kind of hard to follow. If you're not, if no one's finding this valuable, you could, another thing you could do is just kind of read through this. It's actually, all these things, by the way, that's referring to like segment 14.1. That's a section in your book in chapter 14, and you can get a lot of value at this point, I think, now that you kind of know what the basic issues are, of just sitting down with the book sometime and going through that stuff. I know a lot of people often think of a source to turn to, but all of this kind of stuff we're doing adheres to the book really closely. So, with some minor differences in how we're setting things up, but the same ideas apply. So here's how the get node at method works. But again, I'm recommending that we just do that code right in the middle. I'm going to skip through some of this stuff because I don't think there's a lot necessarily of insight necessarily. But there are some technical issues at the end. Like they propose, and here's some interesting concept stuff, right? if you want to keep adding items to the end of the list over and over again, and every time you have to add something to the end, you've got to start a reference, a current node reference at the beginning of the chain, and advance it over and over again until you get to the last node of the chain. If you keep on wanting to add items over and over again to the end, it's a very common thing when you create a list to just keep adding stuff to the end of the list, right? But it's very inefficient to have to start at the beginning with a reference each time and go all the way to the end, right? No, I'm going to add another guy. Okay, I'm going to start at the beginning, go all the way to the end. Okay, add another guy, start at the beginning, go all the way to the end. It's very redundant. Well, you could streamline that process, especially if you're expecting it to happen a lot, by maintaining a last node reference in your class as well. So you could have we have a reference to the first node. Why not also maintain a reference to the last node in the chain? If your software keeps updating that last node reference as well, then when it comes time to add a new item to the end of the chain, you already have it there, right? It's just going to always be there. So that will save you time.
I have a question.
Yep. Go ahead.
Since we wrote the node class ourselves, would it be a bad idea to add a data field that tracks a position, or?
If you wrote the node class yourself, would it be a bad idea to write a method that tracks the position of the node?
Yeah, like add a data field.
Like a special data field to keep track of its own index number or something, so the node knows where it is in the chain?
Yeah.
It's an interesting idea. But I'd have to sort of think, what would the node, how would that help the nodes work? The node really isn't that, doesn't really need to be that advanced.
Right.
Jacob, you have a comment on it?
Whenever you add a node in the middle somewhere, you're going to have to update that value for every other node.
Yeah, and then, right, yeah, if you add something in the middle, then all those node indices would have to be modified, which would take extra overhead. But that would sort of make it kind of like an array where each item is at a particular index, and if you want, so if you wanted to, the advantage is, right, if you wanted to find something at position 5, you could just iterate through all the nodes until you find the one that has a position 5 in it. Which is an interesting idea. But yeah, these are the kind of high-level design things. It's a really good thought, and it shows that you're kind of thinking, about the consequences of these things. And that's kind of a big outcome for the class, is to kind of get people to be able to reason through, some of these larger conceptual issues.
Okay, thank you.
Yep. So I think that's kind of most of the things. By the way, there's a preview too of next week. This thing, if you actually do read the chapter, you're going to read about big O and stuff, which is a just really important concept we're going to talk about, which relates to the execution speed of an algorithm and how it grows, how the time it takes to process an algorithm depends on the size of the data structure that you're working with. So like the two-array method is considered an O of n method because if you have n items in the list, you're going to have to basically do n kind of copies to get all the items dumped into an array. And some methods are like O of n squared, which is a much worse. Some methods are like O of log n, which is much better. It's in terms of how things scale, and this doesn't have to make any sense to you. Some methods are O of 1, which means it takes the same amount of time no matter how big the list gets. Like if you want to add something at the beginning of a linked list, it's O of 1. So these are other kind of big picture reasoning things that we're going to throw at you next week as we start looking at sorting and searching methods. And then you can start to, it's a way of kind of comparing these things. You can kind of compare the performance metrics of these different algorithms inside the different ways of defining the list. And you can use that in your selection process on whether, which one to actually go with. So, fun stuff, and that is all for the And now we can kind of look a little bit at the lab handout, kind of give you a heads up. So we're doing part B. These are all the methods. Pre-lab visualization. Again, kind of showing you what happens when you add these items to a list. In this case, we're going to maintain the order of which they're added. And here are some, again, you should have this you should have this handout available while you're doing these, because you're going to want to look at some of the diagrams. And it looks like we've already got constructors and these various methods provided. And all you're going to do now is start working on these methods: get entry, add, remove. So these are going to be really fun. And I expect to be helping a lot of people today. Oops. So again, these diagrams are kind of giving you different ways of looking at what's happening in the bag, or in the list. I'm going to say bag now. So the first thing actually we're going to write is the plain old add method that just takes the item, and this method has to always add the new item to the end of the chain. This is the method where you just keep saying add, right? You're not giving it a position, but in this case you have to do a little extra work because you have to iterate a node reference to the end of the chain so that you can add something to there. If it's empty, it's pretty easy because we've done that already. So basically the algorithm is going to be to basically follow these steps. I'll let you kind of think through that. Then you're going to write the get entry method, which is going to return a value at a particular location. And then the big challenging one is problem 2, which is the add with a position location. More diagrams there to help you. I'm going to do some remove and replace. I think I do have an optional thing here. Again, that's not optional anymore. I have to take that out. I thought I got rid of all my optional things. I really want you guys to practice this because it doesn't help you to kind of make these things optional. You really should get any kind of practice you can in this stuff. You can't get too much of this stuff. It's really challenging. The more you practice, the easier it gets. Someone is texting me like every 5 seconds. I have to figure out who that is. I know. Got to stop sharing my number. Yep.
Were you using a get node add method, or were you?
Well, let's take a look. I think I took that out because I don't think, I don't know, I just don't like that style because it's just more of a pain. It's a private node class. Why should we go through all the headache of making all these, getter and setter methods when we're the only ones that are using it, right?
Right.
So, we're not going to maliciously try to hack our own list, right? So,
Hopefully not.
yeah, unless you're somehow locked out.
Otherwise, we're in trouble.
Yeah. So, we've got our private node class, and we just have the constructors. Oh, I guess there is the get data, set data. Yeah, if you don't make those private, you will have to use those, right? But I don't care. If you want to make those public, that's fine with me. That will allow you to access those fields directly. And you don't have to use the get data and the set data. I don't know, some people might like those because it's maybe a little more explicit on what you're doing. It's really optional to me. I don't mind either way. What do you guys think? You agree with me? Okay, good. Testing, testing, test, test, test. Yeah. Anyway, as I was saying, this is empty method is kind of interesting because it's if the size is 0, it's verifying. This assert statement is it's like an interesting thing. It's sort of it's a verification step, and you can use this in your development of software. It's sort of like an exception handler, but it doesn't actually process the error state. It just makes your program stop, and then it gives you the message of an assertion that has failed. And I was supposed to lecture on this, I think, maybe on Monday, and I decided to blow it off, and now I should probably tell you about it. It's the thing about asserts is that you have to turn them on, and I don't know if I'm not sure. So let me just try a simple statement here. I'm just going to assert false. And I think you can put a message also. That's not the right syntax apparently. So let me just test false. And I think my system really needs to be rebooted. And this is what happens when you get an assertion where you have a false condition. So what assert allows you to do is put like Boolean logic statements in parentheses that you want to make sure are true when a certain thing has happened. And then if it's not true while you're developing the software, your program will just halt there and let you know that something failed. And I think I am now thinking there's a reference that I should have put for my website. I don't think it's on the class. I'm going to pull this up real fast from my old web page, which is some notes on how to use asserts. Gosh, the system is just so slow. I might have to just stop and reboot the thing. But notes on Eclipse and BlueJ. I'll post this on the main thing. If you want to use Eclipse, it kind of tells you some pointers on how to import projects and stuff from BlueJ. And oh yeah,
BlueJ version. Oh, much better now.
A new BlueJ version?
Yeah.
Okay. Actually, the fact that I got that message is that asserts are enabled. But if asserts are not enabled, you can activate them with this statement, bluej.vm.args equals -EA. And that's in the compiler options, which is in the... it tells you how to get to this file. It's in the BlueJ devs file. But I think they're active, and you can test this. Does somebody want to try this real fast just to make sure that because you might have a different version than I do. In your main method, just put a statement that says assert false, and then run the program, and it should give you a Java-lang assertion error, which means the assertion failed. And let me know if it did. If it doesn't give you that error, then assertions are disabled. And the nice thing about that is, like, when you're developing your code, you can have it trigger those assertions. If you failed an assertion, you want to know that. But then once you are ready to release your code, you don't have to remove all those assert statements. You can leave them in there, but just deactivate assertions in your compiler, and then it will just ignore those. Did anybody get any response from that?
It didn't work.
It didn't work for you?
No.
Did you get it?
Yeah.
You did. Okay. You guys got it. Did you? When you run it, it'll give you a assertion error. Yeah. Good. That's what you want. That's good. And yeah, you want it to give you that error. And I need to pull up my presentation on assertions. Slow. Yeah, I saw this. I don't know why I didn't actually add this. I thought maybe I didn't need it. So here's how assertions actually work. This is a really brief lecture. I'm trying to keep this pretty fast. But what you do, like if you want to make sure something is true and you're just not positive that your code's going to work, or there could be some situation you haven't thought of and so it may not be true, you put an assertion statement in your code, and then it's just a Boolean statement. Like you might want to assert that some variable is bigger than 0. Or here, suppose you have an array of positive integers, and what you've done here is essentially you're sort of looking for the maximum item in the array, and you might decide to follow that up with an assertion statement. You know basically at this point that max has the largest item in these collection of items in the array. That would be an assertion that you're pretty sure is true. Now, that's kind of hard to actually write a statement for, but some things you can write a statement and the compiler and the runtime environment will actually check it for you. These are some slides from the Oracle Academy. It's a good professional thing to know about, right? And assertions can be used to check the internal logic of a method for these things called invariants. What is an invariant? I think it's just something that must be true in order to kind of continue. Since they can be disabled, you don't want to use them to check parameters or anything like that, or any kind of side effects. But the syntax basically is if the expression that you put is false, it's going to throw an assertion error, which is good. You want this, it's going to sort of help you catch runtime errors. And you can have a second option, argument. Oh, I see, you put a colon after it. I wish my computer would actually work. Never seen it this slow before. Yeah. So like maybe you're trying to process like a different number of different suits for a card, and the switch statement, you could pass a suit to it and you can handle it if it's clubs, diamonds. It needs to be flagged, so I'm going to just put a false in there, and this is my message that comes out. And back to our original example, you could put a message here that says it looks like you don't even need parentheses. You can just assert false colon testing assertion operation in your program, and it compiles, and then you run it. And now you get a message too. It says testing assertion operation is what it spits out when that assertion is false. Now right now it's going to always say that. So usually what we want to do is put it in situations that we want to just verify that something is true. And going back to the LinkedList class, you see what it's saying here. When it says assert first node equals null, what does that mean? This is kind of, isn't this, it's sort of checking for consistency, right? Like if your size is 0, something else must be true, right? If the size of your list is 0, the first node should have a null reference in it, right? What if it doesn't? Then your my size is not consistent with the actual structure of your list, right? Something is out of whack. And, you know how confused you are right now, right? You would kind of like to know if things are not actually lined up right, because that could save you debugging later, right? So this is a good kind of safety debugging check. Apart from using a debugger, it's just a really nice built-in thing you can do. If you can kind of predict where things might go wrong. So if my size is 0 and first node is not equal to null, this thing is going to crash and just say, sorry, you didn't make the assertion, right? There's something inconsistent about your list right now. And you could give a little message here, like you could say colon, and you could explain the situation that would actually trigger this, right? This is going to be triggered if, first node not, not equal to null in an empty list, right? So the list is empty and first node not equal to null. You could say it in a number of different ways, right? But that's the situation that's going to happen if this assertion is triggered. Otherwise, and what's this situation triggering here? First node not equal to null, assert first node not equal to null. When would this actually happen? When would this go wrong? When would this be false? This is a situation, it's the opposite situation where, my size is actually like, say, 5, but my first node pointer is null, in which case I have no items in my list, right? Another inconsistency, right? My size and first node are not in agreement, right? So you could say, first node is null with my size greater than 0, right? That's going to flag that situation. You might actually be more precise here, with my size equals 0. So that gives you some more insights into what's going wrong in your software. It can kind of help you find the error quicker. Oh, don't put a semicolon there, that's a colon. Okay, so anyway, you might experiment with those, and if you like, I can kind of guide you some of those things. I'm going to be helping people debug, and these are kind of fun things to kind of put in place. So maybe, would you like to do problem 1 together? Would people like to do that together, just to kind of get one thing out of the way? Because you're going to have plenty of opportunity to get stuck in the other add method. So we have to write the add method, and and we also have to write the getEntry method, because the display list method is going to invoke getEntry on all the items. So we have to write these 2 methods, and then we're going to try those out. We're going to go down to the add of a new entry. And again, there's sort of 2 situations here, right? There's one situation where the size of the list is 0, right? So we could say something like if, my size equals 0. In this case, it's an empty list. Else, in this case, it's a non-empty list. If it's an empty list, it's pretty easy. We make, actually, in the general case, they do this thing where let's just make a new node variable, which is a new node of new entry and null. And if if my size is 0, what are we going to do? Sorry? If my size is 0, this is the add method, right? If my size is 0, we created this new node, and if my size is 0, what do we got to do? Put it in front. We just said first node equal to new node, right? Yeah. And my size plus plus, right? if you forget to say my size plus plus, then the next time you check is empty, you might have this assertion message waiting for you, right? That's the thing that can help you, right? So, but we're going to not forget it, so we're going to say my size plus plus. So that's the easy case when it's an empty chain or an empty list. The other situation is where it's not empty, and in this case, what our lab says, let's look at what our lab handout says. Can't wait to reboot my machine. So here, if my size is 0, we just did step 2 here. Now we're going to do step 3. Otherwise, we're going to make a variable last node, right? And last node has to start at the first node. It's better for me to show you, I think, the diagram so that you don't just watch the code. You really want to see and visualize what's happening here. You could just scroll up a little bit. Come on. There we go. So we've got this new node, and we've got our list here. And we want to basically have last node reflect chain in the last node in the chain. And then we can redirect last node next to equal new node, and then add one to my size, and we'll be all done, right? So that's the step here. So just not in control here today. So we're going to make a variable last node, initialize it to first node, and advance last node to the end of the list as long as last next is not null, advance last node to the next node, and assign to last node the next address of the new node, add one to my size. So here we go. So we make this last node a reference, and we assign it equal to first node. Did we create a node here? No. Right? We didn't create a node. We're just pointing to the first node of the chain with this last node reference, right? So it's basically an alias. It's another pointer to the first node of the chain. And our job is to advance that pointer, so we're looking at the last node of the chain. There's actually 2 ways you can do it. You can make a for loop that repeats like my size minus 1 times, right? If your size is 3, and you want to point to the last node of the chain, how many times should you advance the last node pointer? Twice, right? So if my size is 3, so you would basically make a for loop that repeats my size minus 1 times. And do that, right? But that's a little dangerous, especially if you might have forgotten to increase my size last time. These things can happen, and maybe you don't want to have a crash. Although, why not? That's how you find out something's wrong. So a safer way, though, is to say while last node dot next is not equal to null, right? We can look at last node dot next. That's the node that comes after the node that we're currently pointing at. And if that's null, what do we know? Then the one we're looking at is the last one in the chain, right? If last node dot next is null, then we better stop because last node is pointing to the last node of the chain, right? That's the condition that we want. And is there any way we could get a null reference error at the beginning? Like, what if last node is null? Then we can't access last node.next. Could that happen in this particular part of the algorithm of the method?
No, because my size is not 0.
Yeah, because my size is not 0. It could happen if, again, if we didn't, if we're not consistent between my size and the list. But if everything is done properly, we shouldn't actually get a null reference error. So actually, this is just kind of a one-liner. You don't even need curly braces. You could just say last node equals last node dot next to advance to the next node. Now this is where you can do an assert, but this is not an assert that you can actually write code for. But what should be true at this point after this while loop finishes? Yeah, last node next is null. But in English, you could say that last node now points to the last node of the chain, right? My computer would wake up, now points to the last node of chain. There's no real easy way to write an assert Boolean, expression to make sure that's true. But again, these are the kind of the tropes, the style of coders to write these assertions. And basically, it's just kind of, clarifying your reasoning at this point in the program, right? You're just saying, well, I know at this point then my last node should point to the last node of the chain. Now that we have last node pointing to the last node of the chain, we can assign last node.next equal to new node, right? You can say last node.next equal to new node, and then we can add one to my size. Okay, we can compile that, make sure it compiles okay. Mine's okay, so if you have any errors, let me know before I move on. Any errors? Okay, the next thing is the getEntry method. So getEntry needs to return the item at a particular position. And we'll start off looking at the code again here, or the handout. So when we say get entry of 3 in this particular case, we're going to return the number 35. Okay. But then we also, just like before, we want to make sure we don't try to get an entry for an illegal value. So if we do try to do a get entry of an illegal value, we should return the value null. So before we even start, we should check to see if given position is a legal value, right? If given position, we can do the logic for illegality. So in other words, if given position is less than 1, right? Or given position, okay, greater than what? Greater than my size? That sound right? See if you have my size is 4. Okay. Cool. Anyone having any? Yeah, I think everything's going okay. We're a little short on students today, but otherwise, not too bad. Given position greater than my size would be another illegal thing, right? If given position could be equal to my size, that's okay. But if any of those are true, then we're going to return a null. Otherwise, we're going to need to advance the some kind of a reference to the right location. So we're going to say node, current node, equals first node. Again, we're not making a new node. We're just referring to the first node with another reference. And here's where a for loop might be good for k equals, int k equals. Okay, but we got to think this through, right? So if given position, again, is 3. How many times do we need to advance the current node? Again, twice, right? So you can say, let's see, if k equals 1, k less than given position, is that going to work? So if k is 1 and given position is 3, when it's 1, we'll do an advance, then k, k plus, then k will be 2. That's still okay, so we'll do another advance. Then when k is 3, that will be not true, and so we'll stop. This should actually work okay. And we should be at a valid location because we checked for any illegal positions that might have been given to us. So the last thing we have to do now is just return the data field. So we're going to return current node dot data. Spelled given position wrong. Okay, that should do it. And we can now try to run this. And check to see if everything is okay. So the list should have these items, and it's telling us what we got. It looks like we have a match. Okay, so that works good. One thing though, that if you don't have something that works right, again, I want to kind of instill on people to start using the debugger more. So I've been meaning to kind of make a debugging video, but I haven't had time. So let me just show you, like if you think something's going on that's not correct, what you can do is put some breakpoints in your code. By the way, your code has to compile first. Maybe somehow, like when we added 25, something weird was happening. So if you suspect something's going on at that point, you can make the program at runtime stop at that line, and then you can kind of look at the contents of the various variables. And when we compile the code, actually it already compiles, so you don't have to worry about that. When you run the code, it's going to halt at that point, and it's going to show you a list of your variables that you can refer to in main. And the variables that we have are mylist, which is the only thing we got. We only have this one variable, which is what we really want to see. And you can click on mylist and see what's contained in there. Mylist is a reference to a linked list object, and it's telling you that you have a first node reference and a my size variable, and the first node is pointing to something as well. You can see what's in my first node by clicking that arrow here, and this is the contents of your first node, which says you have a 15 and a null in there, right? And that's what you expect to have happen after you did that first add method. And the debugger has stopped right before executing the add 25. Now you have two options when you're running this thing. You can do step, in which case it's going to execute that statement and go on to the next statement. And now we will have completed this adding of 25. And you can check your variable again to see, is it correct? Okay, my size is 2. That's good to know. It's consistent, right? And you can look at the reference here and see what's in your chain. The first node is referring to a 15. You can look at what that node is referring to by clicking on that arrow, and we now have a 25 with a null in the last node. So that's okay too. If you suspect something weird is going on inside the add method, and you want to kind of explore what's happening in there, you can click on the step into thing. For some reason, oh, I do have instance variables now. That's good. Okay. And Oh, interestingly enough, it says I have assertion disabled variable that's set to false. That must be, is that in my environment? Or is that somewhere in my, I have to look, I don't think I put that in there anywhere. Anyway, it's interesting. Yeah, but you can see that I have a reference to my first node variable, which I can look at again and see the current, status of my list. And then I can step through these lines and see if anything weird is happening when I do that. It takes a little practice to kind of get comfortable with this. But if you can do this, you will free yourself up from having me, find your errors all the time, which I don't mind doing because I know a lot of people need that. But eventually, you want to become self-sufficient where you can kind of find these errors yourself. I know a lot of you are at that point where you can do that, and this is going to really make that possible for you. Now I can look at things. Unfortunately, see, I can't look at my local variables, which is annoying. The debugger should have a last node variable in here that I could look at, but it just doesn't. So it has some issues. And as one person was saying, if you just want to add a bunch of print statements in your code, that's another way to debug it. It just takes more time. But I will start. If you do call me over, I will. I might often ask you to activate it so we can kind of look at it together. Sometimes I just I'm not as good as I used to be. I used to be able to just look at the code and see exactly where the errors are, and I'm just like, oh, I'll just use a debugger. Well, when you've been doing this for 16 years, you're just like, oh, you'll figure it out. Yeah. Okay, so I'm going to leave you to your own devices now. You've got the first problem solved, so now you can start working on problem 2. I'm going to alleviate the load on my computer. I'm afraid the video prognosis is looking pretty questionable. I don't know what it's doing. Oh, it's still recording. All right.